In this video, we will be tackling about symbols and standards in pneumatics. 3.1 Symbols and descriptions of components. The development of pneumatic systems is assisted by a uniform approach to the representation of the elements in the circuits. The symbols used for the individual elements must display the following characteristics. Actuation and return actuation methods. Number of connections, all labeled for identification. Number of switching positions. General operating principle. Simplified representation of the flow path. The technical construction of the component is not taken into account in the abstract symbol form. The symbols used in pneumatics are detailed in the standard DIN ISO 1219, circuit symbols for fluidic equipment and systems. The relevant standards for the construction, testing and design of pneumatic control systems are listed in the reference section of this book. The symbols for the energy supply system can be represented as individual elements or as combined elements. If a standard and common air supply is used for all components, then the simplified symbols can be used. Let us now proceed to symbols. Supply. Symbol used in energy conversion and preparation. Compressor with fixed capacity. Air reservoir with T-junction. Pressure source. Service equipment. Filter. Separation and filtration of particles. Water separator, manually operated. Water separator, automatic. Lubricator. Metered quantities of oil passed to the airstream. Pressure regulator, relieving type vent, hole for excess for upstream, pressure adjustable. Combined symbols. Air service unit. Filter, regulator, gauge, lubricator. Simplified air service unit. Simplified air service unit without lubricator. Directional control valves, symbol development. Valve switching positions are represented as square. The number of square shows how many switching positions the valve has. Lines indicate flow paths, arrows shows the direction of flow. Shut-off position are identified in the boxes by lines drawn at right angles. The connections inlet and outlet ports are shown by lines on the outside of the box. The directional control valve is represented by the number of controlled connections, the number of positions in the flow path. In order to avoid faulty connections, all the inputs and outputs of a valve are identified. 2. The digit on the left is the number of ports, and the other one is the number of position. 2. Way, directional control, valve, normally open. 3. Way, directional control, valve, normally closed. 3. Way, directional control, valve, normally open. 4. Way, directional control, valve, flow 1 to 2 and from 4 to 3. 5. Way, directional control, valve, flow 1 to 2 and from 4 to 5. 5. Way, directional control, valve, mid-position closed. A numbering system is used to designate directional control valves and is in accordance with DIN ISO 5599-3. Prior to this, a lettering system was utilized and both systems of designation are presented here, working lines, pilot lines. In this video, all connections are identified by means of numbers just like the symbols below. Methods of actuation. The methods of actuation of pneumatic directional control valves is dependent upon the requirements of the task. The types of actuation vary, for example, manually actuated, mechanically actuated, pneumatically actuated, electrical and combined actuation. The symbols for the methods of actuation are detailed in DIN ISO 1219. When applied to a directional control valve, consideration must be given to the method of initial actuation of the valve and also the method of return actuation. Normally these are two separate methods. They are both shown on the symbol either side of the position boxes. There may also be additional methods of actuation such as manual overrides, which are separately indicated. Manual, general, push button, lever operated, the tend lever operated, foot pedal, mechanical, plunger, roller operated, idle return roller, spring return, and spring centered. Pneumatic, direct pneumatic actuation, indirect pneumatic actuation, piloted, electrical, single solenoid operation, double solenoid operation, combined, double solenoid operation and pilot operation with manual override. The non-return valve check valve is the basis for the development of many combined components. There are two main configurations for non-return valves, with and without the spring return. In order to release flow, the pressure force on the spring return design must be greater than the spring force. Check valve, spring-loaded check valve, dual pressure valve, shuffle valve, quick exhaust valve. Most flow control valves are adjustable and permit flow control in both directions. The arrow shows that the component is adjustable but does not refer to the direction of flow, it is diagrammatic only. In the case of the one-way flow control valve, a non-return valve is switched in parallel with the flow control valve. Flow control is effected in one direction only. Flow control valve, adjustable. One-way flow control valve. The function of pressure valves is to influence the pressure in an overall pneumatic system or in a part of the system. Pressure regulating valves are generally adjustable against spring compression. The symbols are distinguished according to the following types. Pressure regulating valve without relief port. Pressure regulating valve with relief port. Pressure sequence valves. Adjustable pressure regulating valve, non-relieving type. Adjustable pressure regulating valve, relieving type. Sequence valve external source. Sequence valve inline. Sequence valve combination. The linear actuators or cylinders are described by their type of construction and method of operation. Single-acting cylinder. Double-acting cylinder. Double-acting cylinder with double-ended piston rod. Double-acting cylinder. With non-adjustable cushioning in one direction. Double-acting cylinder with single adjustable cushioning. Double-acting cylinder with single adjustable cushioning at both ends. Linear drive with magnetic coupling. Rotary actuators. Rotary actuators are divided into continuous motion and limited angle of rotation. Rotary motion. Air motor, rotation in one direction fixed capacity. Air motor, rotation in one direction variable capacity. Air motor, rotation in both directions variable capacity. Rotary actuator. Auxiliary symbols. There are a number of important symbols for accessories which are utilized in conjunction with pneumatics. Single-acting cylinder. Double-acting cylinder. Double-acting cylinder with double-ended piston rod. Double-acting cylinder with non-adjustable cushioning in one direction. Double-acting cylinder with single adjustable cushioning. Double-acting cylinder with adjustable cushioning at both ends. Linear drive with magnetic coupling. Let us now discuss about the safety requirements for pneumatic systems. Safety requirements for pneumatic systems. To date, no standards exist with regard to the safety of pneumatic systems. Therefore, for all factors affecting safety, reference must be made to existing general guidelines and regulations from a number of different engineering fields. An extract from one of the VDI, German Association of Engineers Guidelines number 3229, Technical Design Guidelines for Machine Tools and Other Production Equipment, on the subject of safety states. Safety. Controller malfunction. In the event of controller malfunction or disconnection of the system, operating staff must not be endangered. Emergency stop switch. Pneumatic systems using several force cylinders must be equipped with an emergency switch. Based on the design and operating characteristics of a system, the decision must be made as to whether the emergency stop function is to put the system into the zero pressure status, to reset all force cylinders into the initial position, or to inhibit all cylinders in their current position. These three options can also be combined. Safety requirements for pneumatic clamping devices. Consideration should be given to the following guidelines when operating pneumatic cylinders under clamping conditions. The control system for the pneumatic clamping devices should be designed or arranged in such a way as to avoid accidental operation. This can be achieved by means of manually operated switching devices with protective covers, or control interlocks. Precautions must be taken to prevent hand injuries caused by the clamping device. This can be achieved by checking the clamping conditions by means of clamping cylinder positioned outside the feed area. Use of safety clamping cylinders, which do not apply the full clamping force until they have reached the workpiece, or use of two-hand control. Machines with pneumatic clamping devices must be equipped in such a way that the drive of the working or feed spindle cannot be switched on until the clamping action is confirmed. This can be achieved with pressure transducers, or Pressure sequence valves. A failure of the air supply must not cause the clamping device to open during the machining of a clamped workpiece. This can be achieved by means of mechanical clamping devices, self-locking clamping elements, reservoirs. Environmental pollution. Two forms of environmental pollution may occur in pneumatic systems. Noise, caused by the escape of compressed air. Oil mist, caused by lubricants which have been introduced at the compressor or via a service unit and which are discharged into the atmosphere during the exhaust cycles. Exhaust noise. Measures must be taken against excessive exhaust noise. This can be achieved by means of exhaust silencers. Silencers are used to reduce the noise at the exhaust ports of valves. They operate on the principle of exhaust airflow control by creating a greater or lesser flow resistance. Normal silencers have only limited influence on the speed of the piston rod. In the case of throttle silencers, however, the flow resistance is adjustable. These silencers are used to control the speed of the cylinder piston rod. Another method of noise reduction is to fit manifolds with connections to the exhaust ports of the power valves and thus to discharge the air via a large common silencer. Oil mist. The exhaust air of mechanically driven tools or mechanically controlled machines contains atomized oil which often remains in a room for some considerable time in the form of a vapor, which can be breathed in. Pollution of the environment is particularly acute in cases where a large number of air motors or large diameter cylinders are fitted in an installation. In this case, the use of filter silencers is recommended, whereby the major part of the oil mist is filtered and does not reach the ambient atmosphere. Operational safety. When maintaining or working with pneumatic systems, care must be taken in the removal and the reconnection of air lines. The energy stored in the tube or pipe will be expelled in a very short time with enough force to cause severe whiplash of the line which can endanger personnel. An additional danger is in the disturbance of particles due to the air blast which causes eye hazards. This is the end of the video. Thank you for watching. Please like and share. For more contents like this, just subscribe to this channel. It is Sir Kenny on YouTube. SIRKENNY. Thank you. In this video